All right, salutations. What's going on, mathletes? Hazelton, what? Mr. Nelson here, just to, I guess, pick up where we left off, because we talked in the last video about radicals, converting from entire radicals to mixed radicals and back, and we used prime factorization, primarily to determine if any perfect squares reside within the numbers that we were converting from entire radical to mixed radical. And knowing that for a number sitting outside the radical sign in a mixed radical, in order to go inside that radical, it must multiply itself as many times as as the power of that radical. So if it's a cube root, then any number that wants to be inside that cube root must be multiplied by itself 3 times in order to be in there. So now we are going to, I guess, move on to their cousins, the cousins of radicals, exponents. And there's a few exponent laws, and once we learn those laws, then we can start tackling what look like complicated algebraic expressions and simplify them. And I think it's pretty fun. It's kind of like solving a puzzle. But in order to solve a puzzle, you have to know the rules of said puzzle. So what is an exponent? Well, any number a to the power n here, to the power of a number, this is the exponent. Okay, so if I have 2 cubed, what does that tell me? It just tells me that I need to multiply 2 by itself 3 times. So 2 times 2 times 2. If I had x to the power of 3, or to x squared, it would tell me that I have to multiply x by times, I'll do a dot for the times here, x times x. If I had y to the power 4, it tells me I have to go y times y times y times y. And then we haven't even seen binomials or polynomials, but if I have x plus 2 squared, it just tells me that everything inside here must be multiplied by itself twice. Okay? This is what exponents tell us. So in this video, I'm just going to talk about two baseline, what I consider baseline laws. So those laws are 1. And I want to do this in red. Is this important? Exponent laws. Here they are. 1. A to the power of 1 over any number n is the same as writing the nth root of that number a. So what does that mean? Well, that means that if I have if I have x to the power of 1/2, that's the same as the square root of x, because there's an invisible 2 there. If I have the cube root of 3, that's the same as writing 3 to the power of 1 over 3. If I have the 4th root of y, that's the same as writing y, I don't need the brackets there, y to the power of 1 over 4. And if I have b to the 1 over 5, I can write that as the 5th root of b. Okay? So that's fairly straightforward. It's just, there's this number down here, n. It matches up with the n with whatever root we're dealing with there. Okay? And the second complementary law here is actually, so a to the power of negative n is the same as 1 over a to the power of positive version of that n number. And on the flip side, 1 over a to the negative n, any number a, any number n, is the same as writing a to the positive n over an invisible 1, it flips. So what does this mean? It means that exponents are really optimistic. They always want to be positive, or at least they want to be expressed as positive. they identify as positive. So if an exponent happens to be negative, it's just telling you, bro, I'm just not happy up here, I want to go down there. If a negative is negative down here, it's like, yo man, good times up top, but the sun don't stop. So they want to go up there. And this works, so if I had x to the negative 3, I could rewrite this as 1 over x to the power of positive 3. If I had 1 over x to the negative 5, I can rewrite this as just x to the power of 5. When it's negative, it's just like, yo man, I am in the wrong place. This also works with situations like this. If I had a to the negative 6 over b to the negative 5, for example, well, in this case, we're just going to get a little fliporama. We're going to get b to the power of positive 5 over a to the power of positive 6. As long as there's no addition signs in here, and everything's being multiplied by each other, we can do this. So if I had a to the negative 2, b to the negative 3 over, say, c squared, well, in this case, there's no addition signs, it's just a multiplication and division. These two numbers are unhappy because their exponents are negative. So what we can do, and they want to go down here, but if they go down here, there's going to be nothing left up here except for a 1, and that's okay. So we get 1 over a squared, b cubed, c squared. These guys come down and just multiply with the c now. They're allowed to do that. Here's another example. If I had b squared, well, let's try different letters for a change. So if I had x to the negative 2, y to the negative 3 over b squared, c to the negative 4. Well, in this case, these three exponents are very unhappy, so they're all going to flip. So what do we get? Well, we get c to the power of 4 now over x squared, y cubed, and then the b stayed down there because it was perfectly content under the bridge there. So that's what the negative and positive exponents tell us, and we can do this as long as there's no addition signs, breaking up the multiplication or division. Okay? So in the next video, I will introduce the power of power laws, likely the quotient law and the product law, which complement these laws as well. But I think these laws are important to know how fractions and negative integers affect exponents. So thank you for watching. Practice, do a lot of problems. I know that when I was your age, I went to absolute war. Well, no, I had to put in the time to understand these laws. But once you kind of figure it out, it's not so bad. Just like anything in math, if you just put in the time, you learn the rules, you practice, you're gonna be fine. Okay, have a great day. Bye now.